To demonstrate how we can compute z-scores from raw data in Excel, I've created exam scores for 19 hypothetical students. And so what I'm going to do here now is go up under the z-score column and for the very first student and demonstrate how to use the standardized function in Excel for computing z-scores. So I'll begin typing in the formula equal, and the function name is standardize, open parenthesis. Now X refers to the exam score, the raw data that we want to convert into z-score format, comma, and now we're going to enter in the mean and the standard deviation. Let's say that I just want to enter in the values of 80 for the mean and the value of 7.8 for the standard deviation from which this case actually comes from, and hit return. And right there we have a z-score of 0. But that's not a very flexible formula or use of the standardized function. Instead, what would be a better use of it is to use the cell references for the mean and for the standard deviation that I've already computed here and hit return. It doesn't change the value here. It's still a 0. But let's go ahead and make these fixed references, because what I'm going to do now is to copy this formula down for the other students instead of typing it in for each one. Hit return. And now as I copy it down, it's going to keep fixed the location of the mean and the standard deviation, but it will adjust then the X value or the raw score value down for each individual student as we want. And there we have it, z-scores for each of these exam scores. Now typically what I do is I report my z-scores to 2 decimals, typically the norm. And there we have z-scores generated using the standardized Excel function. Now, if you wanted to, you could even make the z-score formula here even more general. Let's assume that we had not actually computed the mean and standard deviation beforehand, and so instead I can then use the standardized function but embed in that the average and standard deviation functions. So equal, standardize, open parenthesis, again the same raw data, comma. Now let's type in the average function, and I want to take the average of all of these data points here. There we go. Comma, and let's now type in the standard deviation, and I'll use the sample formula, that function name, and again I will highlight those same cases. Close parentheses to close the standard deviation function, and then close parentheses to complete the standardize function. Now I'm going to keep constant the range of data points for finding the mean and for finding the standard deviation. There we go. And if I've done this properly and I copy this down for all the other students, we should see the exact same z-score values. And to make it clear that the same z-score values, I'll convert those to 2 decimals. And that's how we go ahead then and use the standardized function in Excel for computing z-scores. And I've demonstrated how to do it a couple of different ways. Now I'm sure that you can see that I don't even need to use the standardized function in Excel to compute z-scores. Let me go ahead and just demonstrate how I would compute it using the formula of x sub I minus x bar, that whole quantity divided by the standard deviation. So equal x minus x bar, which is the mean, and I'll put that in parentheses, divided by the standard deviation for that variable. And what I want to do now is to make the reference to the cell that contains the mean and standard deviations fixed. And as I copy them down, you'll notice it's identical to what the standardized function generates for us. Or I can make this even more sophisticated of a formula, if you will, more complex, by equal, again, take the raw score minus, and let's say I use instead the average function. So perhaps I hadn't already computed the mean, close parentheses, divided by, and I'm going to use the standard deviation, the sample function for the standard deviation. Now let's make sure I get the parentheses correct. I want to have a parentheses around the x sub I minus x bar. That looks correct. And now I also want to make sure that the reference to the range that contains the data for finding the average is fixed. And I will do the same thing then for the cell references for the range that we use for finding the standard deviation for these data. Let me take a quick look at it, make sure that that looks okay, and I think we've got it. Go ahead and hit return. And now as I copy this down, again it generates the exact same values. So whether we use the standardized function or we just type in ourselves the complete formula for a z-score, it's pretty easy, you can see, in Excel to convert exam scores or raw scores into z-score format. Now that we've computed z-scores for our original exam scores, we can go ahead and use another Excel function to find the percentile of each z-score value. And what I'm going to use here is going to be the norm.s.dist function. Norm.s.dist. Now the norm refers to the normal distribution, as does the dist distribution, obviously. And the S refers to standard normal distribution. Now the standard normal distribution is the version of the normal distribution that has a mean of 0 and a standard deviation of 1. Open parenthesis. Now we then highlight the z-score value we want to find the percentile for, comma, and now we type in a value of 1. The 1 refers to a cumulative distribution. The cumulative distribution refers to the idea of the percent of the area under the curve, or the entire area under the curve, that falls at or below a given z-score value. And that's what we want for a percentile. And hit return, and we see it has a value of 0.50. Now this 0.50 here is proportion of the area under the curve. Typically what we'll do is we'll report percentiles as though they are percents. So we'll multiply this by 100, not as a proportion, but as a percent. And there we see 50th percentile. So an exam score of 80, when the mean for a group is 80, has a percentile value of the 50th percentile. And I'll go ahead and I'll drag that all the way down. And what you'll notice here, now we have percentile values for each one of our exam scores. Now typically percentile values are rounded off to the largest whole number, and so let me go ahead and do that. And right there we have it, percentile values that were identified once we have z-scores using the norm.s.dist function. But we can actually find percentile values straight from the raw exam scores themselves without even having to compute z-scores. And let me show you how to do that. So I have here a second sheet here for percentiles, and you notice I do not have a z-score computed for each exam score. What we're going to use here is going to be the norm.dist function. and again identify the value of the exam score we want to find the percentile for, comma, and now we have to tell it exactly which normal distribution, and that requires us identifying the mean and the standard deviation. So we'll come down here and identify the mean for our exam scores, comma, and also the standard deviation for our exam scores, comma, and one last parameter we have to specify, and that being a value of 1. The 1 refers to cumulative, all the area under the curve up to and including a given exam score. Now I'll hit return, and let me go ahead, since I'll copy down this formula in just a moment. Let me go ahead and make sure then that I have a fixed reference for where the standard deviation and mean values are. But in addition to that, the 0.5 refers to proportion of the area under the curve at or below an exam score of 80, when the mean of the whole group is 80. What we want to do is now multiply that by 100, so it's percent of the area under the curve. Let's put it at the end here of our formula. Hit return, and now it's percent of the area under the curve at or below that exam score, which is 50%, 50th percentile. Click and drag down, and again I'll just go ahead and reduce that to no decimal points, no decimal places rather, I should say. So what we have here now is the percentile values in whole digits. Now that we worked from raw score to z-score to percentile, what I want to do is demonstrate how we can work from percentile and go backward to z-score or to raw score. The first illustration of this, let's assume that once we've computed our z-score values for each student in this class, I then decide as the instructor to curve the grades. And looking at my percentage distribution over here, let's say I decide then that the highest 7% of the exam scores will be awarded an A. The next 24% in rank order would be awarded a B. The middle 38% would be awarded a C. The next 24% in rank order would be awarded a D. And the lowest 7% would be awarded A and F. Well, when we think about that then, what that would translate to is, first of all, the 7th percentile and below represents the F range. The 31st percentile indicates then the highest value for falling into the D range. The 69th percentile, what I'm doing is adding these percentages as we go up, represents then the highest value but still falling in the C category. The 93rd percentile then would be the highest value but still falling into the B category, and all those above it would be awarded an A. Now you'll notice here that under this column I have a value of K, which is nothing more than a percentile in proportion form, and that's what we need to enter when we actually then compute the z-scores based on a percentile. What I'm going to use here is going to be then, and I'll start right up here with the B category here, is going to be the norm S inverse function equal norm dot S, and again the S refers to the standard normal distribution, dot inverse, so working backwards, open parentheses. Now all I do is identify then what is the probability. This probability value must be between 0 and 1, so it cannot be 0 and it cannot be 1. Close parentheses and hit return. And I can drag that down for each one of these. So you notice just highlighting this here, this goes and finds then the z-score associated with a probability of 0.69. This next, a probability associated with 0.31, and next the probability associated with 0.07. And let me go ahead and reduce this to 2 decimals. Now I do not have a value that's reported up here, and let me show you what happens when I actually do. Then I'll put here a probability of 1, which would be the highest. 100 would be the highest value here, the 100th percentile, which you never really hear anyone referring to the 100th percentile. It doesn't really make sense statistically. And we'll show you why. Equal norm.s.inverse, open parenthesis, click on the probability of 1 and hit return, and it returns an error message. Statistically, it doesn't make sense to refer to the 100th percentile, and that's why it returns an error message. So the probability values here must be between 0 and 1. And that's what we're left with right here. Now we can do the exact same thing if we look just at the exam scores. Ask what is the what is the exam score value that is at the 93rd percentile, and so on. And what we'll do here is now use the norm.inv, the inverse norm function. So equal norm.inv, and you notice we have more information we have to identify here. We first of all specify the probability value in a proportion. So 0.93 refers to the 93rd percentile, or 93% of the area under the curve. Comma, now we identify what the mean value is for this distribution, comma, and identify what the standard deviation value is for this distribution. And now we hit return. And let's go ahead and now we want to copy this formula into the cells below. And so let's go ahead and make the reference to the cell that contains the mean and standard deviation values as fixed references. And now I can drag this down. And let me go ahead and reduce this to whole numbers, which is what the exam is graded in. So in this case, it indicates that anyone who scores a 68 or below will be awarded an F. That's the 7th percentile and below. Anyone who scores now between the 7th percentile and the 31st percentile will receive a D, and that's a value of 76. Anyone who receives an 84 down to just above the 76 will be awarded a value of C. Anyone who scores from 92 down to just above 84 will be awarded a B, and then anyone who scores above a value of 92 will be awarded then an A. And this is how we can go from the percentile value and now go right back to find what the raw exam score is by using the norm.inverse function. Another example where we might see that this may be useful, going from the percentile back to a score, relates to membership in the International Mensa Organization. You know, the Mensa Organization is the largest and oldest high IQ society in the world. In order to qualify for membership in Mensa, people must score at or higher than the 98th percentile on an improved IQ test or other intelligence test. And perhaps the most common IQ test is the Wechsler Adult Intelligence Scale, or WAIS, and its 4th edition was provided in the year 2008. Now, this particular IQ test has an average for the population of 100 and a standard deviation of 15. With that being the case, and if we have to be at least at the 98th percentile, what is the minimum IQ score in this particular test that we need to attain in order to qualify for membership in Mensa? So in this case, what I've done here is identified 98th percentile. Now I'm going to equal norm inverse, and now the probability is 0.98. That K column is representing the percentile in proportion, which is what we need for its use in Excel here in this norm.inverse function. comma, the assumed population average, comma, the assumed population standard deviation in close parentheses, and hit return. And now it indicates that you need, and let's go ahead, and I think the IQ test is scored in terms of whole numbers. Let's go ahead and reduce that to whole numbers. And in that case, one needs to score a 131 or higher on the Wechsler Adult Intelligence Scale in order to qualify for membership into Mensa. So hopefully now you've got a good sense as to how we can go from raw data to z-scores to percentiles, and from percentiles back to z-scores and also to raw scores.